Okay, so we are on the lesson D in the first unit, and this is not displaying data, quantitative data with graphs, but with numbers. And so we're going to talk about different ways to do that. So we're going to start with measure of center called the median. You probably know that word means the middle or center. So it's the midpoint of the distribution. First, you always have to organize the data from smallest to biggest before you find the middle number. So don't forget to do that. It's really easy to forget to do that. If there are an odd number of data values, then the median is literally the middle number. If there's an even number, you're going to have to average the two middle terms. So whatever those data values are, you'll have to average them. So in this case, population density of different countries, 1, 2, 3, 4, 5, 6, 7. Yeah, 7. So because there's an odd, and it says 7, because there's an odd number of countries, there is one term in the middle. What I typically do, I'm just going to show you the calculator just so you can kind of see my process. I do 7 divided by 2 is, as a decimal, 3.5. Right, so 3.5, if you round that up, the fourth term should be the middle term. And that works when it's odd. If it was even, I do 8 divided by 2 is 4. The fourth and the next term also, so the one that's divided by 2 and the next term is the middle term. So that's just kind of my method for finding which term's the middle. So let's see, so is Guatemala the middle term? Oops, what did I forget to do? Put them in order, right? So you have to put the data values in order. So now, actually, Honduras is the middle term after you put the terms in order from smallest to biggest. The fourth term from the left or from the right, actually, is 82. You verify it with a dot plot. So you can actually plot them on a dot plot. It's kind of weird to have a dot plot with all different values like that, but that's okay. And again, make sure you label it, population density, people per kilometer squared. The mean is also a measure of center. So mean and median are measures of center. Technically, mode can be a measure of center as well. Mode is the most common term. We don't deal with it much, I don't think. The mean of distribution is the average of all the data values. You add them up, divide by the number of terms. You know how to find that. That's the technical formula for saying that. So if you have this, all these percent of error in the sample of 14 bags of chips, that's crazy, by the way. So Cheetos is 59% error. Wow. So over half the bag is error when you open up one of those things. I've seen that before. It's interesting, actually. So which one is the least? So Pringles. That's true. Pringles fills it up pretty well. So, Fritos. Oh, that's interesting. Fritos, not a lot of play there. So only 19% air. So they tightly pack the Fritos. So we have 1, 2, 3. Well, we don't have to count them for the median. Median, you have to count them here. You just add up all those numbers, divide by 14. Is basically what you're doing. Add them up, divide by 14. You get 42.57% error. If you look at the data, it looks probably skewed left there. So I'm not sure mean is the best measure of center. Usually when it's skewed, we pick the median, but that's probably something we'll bring up another day. Okay, the bag of Fritos is possible outlier. I would say so. Calculate the mean percent of error if you exclude Fritos. So this is kind of interesting. So if we take Fritos out of the equation, so now we only have 13 bags of chips. You add up those 13, divide by 13, you get 44.38. So it was 42.57, now it's 44. So you're off by almost 2 percentage points. So that one bag, because it was an outlier, had a big effect on the percentage of error, on the average percentage of error. So those outliers have a huge effect on the mean. That's even kind of a smaller one, but there'll be bigger effects on the mean. When it's an outlier, it has a huge effect. This is good. I talked about notation is important, and this is true. So for the mean of the sample, we call that X bar when you take a sample. If it's from the population, so everybody that we are trying to figure out something. If it's the population, that's called mu. Greek letters are usually for populations, and other symbols are for samples usually. X bar, the mean. Any sample is a statistic. Any population, anything from a population is a parameter. So, and it's kind of it has alliteration to that. That's how I learned that, is that statistics come from samples and parameters come from populations. So it just kind of alliterates, it just kind of rolls off the tongue there. You kind of get the hang of these new words as we use them more. Resistant, I like that word. So that's which one, it measures resistant if it is not affected by extreme beta values. We already talked about the mean is very affected by an outlier. So I don't think a mean is very resistant. Which measure is? Well, the mean is not, so maybe the median? I think it is actually. The median's going to stay kind of in the middle, but when it's skewed, the mean will get pulled toward that skew. It's the effect of that outlier. That outlier is pulling that mean towards it. So if it's skewed left, the mean is always going to get pulled towards the outlier, and so it's going to be smaller than the median because the median is unaffected or resistant to the effect of an outlier. If it's approximately symmetric, the mean and median should be about the same, pretty close to each other. And then if it's skewed to the right, the mean gets pulled with the skew, gets pulled with that potential outlier there at 12. So the mean is very affected. The median is resistant to the effect of the outlier. So in this case, the mean is bigger than the median when it's skewed to the right. So roughly symmetric has no outliers. The mean and median would be similar. That's true. If it's skewed, the mean is get pulled with the skew there. The median is resistant, but the mean is not resistant. Okay, we're done with the lesson. Let's just do a couple of examples here. So find the median. You have to order the numbers first. Find the two middle numbers. Remember, since there were 20 different crabs, 20 divided by 2 is 10, so the 10th and 11th term. So if you count from the left here, you'll see that the 10th and 11th term are 58 and 59. You average those two, add them up, divide by 2 to find the median. Calculate the mean of this. So you're just going to add them up, divide by the number of terms. In this case is 7. And put in context, always talking context, always put the units there. That's great to do. El Salvador, with a population density of 292 people per square kilometer, is a possible outlier. Yeah, I'd say so. Calculate the mean density without that one. So just the 6 countries without that outlier. So now it goes down to 63.2, just one number off, but because that was such a big outlier, it had a change in 32 people per square kilometer. Wow, so the average changes a lot. The mean is very affected, not resistant to the effects of an outlier, where the median would not change or very little change in the median. That's the lesson for today.